Let's explore the unknown. Hi. Welcome to the exploration of stars. The stars are bodies of hot glowing gas that are born in nebulae. They vary enormously in size, mass, and temperature. Diameters range from about 450 times smaller to over 1,000 times bigger than that of the Sun. Masses range from about a 20th to over 50 solar masses, and surface temperatures range from about 3,000 degrees Celsius to over 50,000 degrees Celsius. The color of a star is determined by its temperature. The hottest stars are blue, and the coolest are red. The Sun, with a surface temperature of 5,500 degrees Celsius, is between these extremes, and appears yellow. The energy emitted by a shining star is usually produced by nuclear fusion in the star's core. The brightness of a star is measured in magnitudes. The brighter the star, the lower its magnitude. There are two types of magnitude: apparent magnitude, which is the brightness seen from Earth, and absolute magnitude, which is the brightness that would be seen from a standard distance of 10 parsecs, 32.6 light years. The light emitted by a star may be split to form a spectrum containing a series of dark lines, absorption lines. The patterns of lines indicate the presence of particular chemical elements, enabling astronomers to deduce the composition of the star's atmosphere. The magnitude and spectral type, color of stars may be plotted on a graph called a Hertzsprung-Russell diagram, which shows that stars tend to fall into several well-defined groups. The principal groups are main sequence stars, those which are fusing hydrogen to form helium, giants, supergiants, and white dwarfs. And let's explore the major categories of stars. The small stars, and the massive stars. Small stars have a mass of up to about 1.5 times that of the Sun. They begin to form when a region of higher density in a nebula condenses into a huge globule of gas and dust that contracts under its own gravity. Within a globule, regions of condensing matter heat up and begin to glow, forming protostars. If a protostar contains enough matter, the central temperature reaches about 8 million degrees Celsius. At this temperature, nuclear reactions in which hydrogen fuses to form helium can start. This process releases energy, which prevents the star from contracting further, and also causes it to shine. It is now a main sequence star. A star of about 1 solar mass remains on the main sequence for about 10 billion years, until much of the hydrogen in the star's core has been converted into helium. The helium core then contracts, and nuclear reactions continue in a shell around the core. The core becomes hot enough for helium to fuse to form carbon, while the outer layers of the star expand and cool. The expanding star is known as a red giant. When the helium in the core runs out, the outer layers of the star may be blown away as an expanding gas shell called a planetary nebula. The remaining core, about 80% of the original star, is now in its final stages. It becomes a white dwarf star that gradually cools and dims. When it finally stops shining altogether, the dead star will become a black dwarf. Massive stars have a mass at least 3 times that of the Sun, and some stars are as massive as about 50 suns. A massive star evolves in a similar way to a small star until it reaches the main sequence stage. During its life as a main sequence star, it shines steadily until the hydrogen in its core has fused to form helium. This process takes billions of years in a small star, but only millions of years in a massive star. A massive star then becomes a red supergiant, which initially consists of a helium core surrounded by outer layers of cooling, expanding gas. Over the next few million years, a series of nuclear reactions form different elements in shells around an iron core. The core eventually collapses in less than a second, causing a massive explosion called a supernova, in which a shock wave blows away the outer layers of the star. Supernovae shine brighter than an entire galaxy for a short time. Sometimes, the core survives the supernova explosion. If the surviving core is between about 1.5 and 3 solar, it contracts to become a tiny, dense neutron star. If the core is greater than 3 solar masses, it contracts to become a black hole. Let's explore the neutron stars and the black hole in the next video. Like, share and subscribe our channel. Stay tuned.